Classifying chemical reactions helps chemists predict the products based on the starting reactants. Many chemical reactions can be classified as one of 5 basic types: combination, also called synthesis; decomposition; single replacement, also called single displacement; double replacement; and combustion. A combination reaction is when 2 or more substances combine to form a single new substance. The most basic combination reaction is when 2 elements react to form a single new compound. Solid sodium metal reacts with chlorine gas to produce solid sodium chloride. Here are 2 important reminders for a combination reaction. First, it's important to note that in a chemical equation, a single element that is by itself is usually just written as its symbol from the periodic table. But there are 7 elements that exist in nature as diatomic molecules. So that's why chlorine is written as Cl2, not just Cl. Second, when predicting the product, it's important to consider the type of compound the reactants will form, covalent or ionic. An ionic compound is formed when a metal reacts with a nonmetal. In this case, the compound is composed of ions and the total positive and negative charges must balance out. Most errors students make with synthesis reactions involve these 2 points. Here are 2 incorrect answers to an exam question that asks students to write a chemical equation for the synthesis of magnesium oxide. In the first incorrect answer, the student didn't balance the charges of magnesium oxide correctly. Magnesium is a group 2 metal, so it will have a 2 positive charge, and oxide is a group 6 nonmetal, so it'll have a 2 minus charge. So the correct formula of magnesium oxide is MgO, not MgO2. In the second incorrect answer, the student predicted the correct product but did not remember that oxygen is a diatomic molecule. So when oxygen is in its elemental form, it should be O2, not just O. The correct synthesis reaction is this. Notice that to make sure the equation follows the law of conservation of mass, coefficients are added to double the Mg and MgO so it matches the diatomic oxygen. Decomposition is the opposite of a synthesis reaction. It's where a single compound breaks down into 2 or more simpler substances. The simplest version of a decomposition reaction is when a binary compound breaks into 2 elements. Predicting the products of these reactions is fairly straightforward. The main thing to remember are those 7 diatomic elements, because they will need to have subscript 2 when they break apart, like mercury oxide decomposing into mercury metal and oxygen gas. To predict the products of decomposition binary compound like this, just write each element separated, and then check to see if they are one of the diatomic elements. Both nitrogen and oxygen are diatomic, so we need to put subscripts 2 after each of them. To balance, I would also need to add these coefficients. A single replacement reaction is when an element replaces a similar element in a compound. Most commonly, a solid pure metal replaces a metal cation in an ionic compound to form a new ionic compound. The metal cation that was replaced forms a solid pure metal. When the metals are switching places like this, the solid pure metal must be more reactive than the metal cation in the ionic compound. Otherwise, a reaction will not occur. When predicting the products, it's important to correctly form a new ionic compound by making the total positive and negative charges balanced out. In this reaction, aluminum is more reactive than copper, so they will switch places. The copper will be solid pure metal on the product side. Then we need to form a new ionic compound. Aluminum has a 3 positive charge and chloride has a 1 minus charge, so we'll need 3 chlorides to balance the aluminum. It'd be AlCl3. We can balance the equation to follow the law of conservation of mass by adding these coefficients. In a double displacement reaction, 2 dissolved ionic compounds react, and the positive and negative ions exchange places with each other. 2 new compounds are formed, one of which forms a precipitate, a gas, or a molecular compound like water, while the other remains dissolved. It's important to remember that the 2 new ionic compounds will need to have the total positive and negative charges balanced out, so you may have a different number of each ion on the product side of the reaction depending on the new ionic compounds. Coefficients are added to balance the chemical equation and ensure the same number of each ion exists on both sides of the chemical reaction. It's also important to remember that in a double displacement reaction, the 2 reactants are dissolved in water, and then most commonly one of the products forms a precipitate, a solid, while the other remains dissolved. The solid substance is often identified based on a set of solubility rules. These rules are commonly available in textbooks and online. A combustion reaction is when a substance reacts with oxygen. Most commonly, a hydrocarbon, a compound made up solely of carbon and hydrogen atoms, reacts with oxygen gas to produce water and carbon dioxide. Although hydrocarbons will have different numbers of carbon and hydrogen, the products are always the same: water and carbon dioxide. Thanks for watching. If this video was helpful, please like it and subscribe to the channel.